Then we continue with a frequency polygon. So the relative frequency of the class interval can also be shown in a frequency polygon. The frequency distribution, the mid value for each class is obtained. The frequency is plotted against the corresponding mid value. These points are joined by the straight line. This straight line may be extended in both directions to meet exit from the polygon. So this is example. So you plot the value for mid value in here. Okay, and then you make the line to continue the see the pattern. I think the current normal, for example, in the Excel we call as a line graph. Okay, line graph. So this is OGIF. OGIF a plot for the cumulative frequency against the upper class boundaries with the points joined by line segment. So this is the example of class 1 is 1554 to 161. So calculate this one. Okay. Frequency, count the frequency, and OGIF is the cumulative frequency. Okay, and then cumulative frequency is the this one. Okay, 4. This means 4 plus 3 in here, you get 7 in here. 7 plus 5, you get 12 in here. So the rest. Okay, so relative frequency, I think you already know how to calculate relative frequency. And then cumulative frequency also, we calculate this one and then times this, and you get this one, this value. Okay, this means this one is 0.01 plus 0.11, you get 0.26. Okay. So and then we got the this is relative OGIF. Okay, relative, you plot the graph based on this value. This is the relative OGIF. For example, the data 0.5 in here 0.5. So this is for 0.01. Okay, 0.015 in here, and then 0.06, 0.65. Cumulative, relative, 0.6 around this one, 0.5 until 0.61 in here, 61 until 0.65 in 168. So 168 until around 0.75 in here, 0.52 in here, and 0.189, right? 179 and 196. So plot the value. This is from this data, relative OGIF. Okay, increase lah. Normally increase because cumulative. Cumulative is increasing. Okay, stem and leaf, another method. Stem and leaf to display is the effective and compact way to summarize for unvariance numerical data. Okay, so this is for numerical data only. Okay, each number in the data set is broken into pieces between stem and leaf. The stem is the first part of the number, consists the beginning digit number. The leaf is the last part of the number and consists of the final digit. Okay, how to use it? Numerical data set is the small to moderate number of the observation. So, bila kita nak guna, how we use it when the data is small. We can use for the big data. How to construct? Select one or more leading digit in the stem value. The trailing digit or sometimes just the first one in the trailing digit become the leaf. List possible stem value in the vertical columns and record the leaf for each observation beside the corresponding stem value. Indicate the units for the stem and leaf some place in the display. What we're looking for this from this graph is represent or typical value in the data set. Extend the split from the typical value, any gaps, okay, represent the any gaps of the data. Extend the symmetrics for the distribution for the value and the number and location of big data. So this example of data, for example, this is temperature data. Temperature data in Oswego in Fahrenheit. So you stamp it, this one is stamped. Okay, the first value in here. So we got 63, we got leaf is the second value. So this is 3 and 3. So 7, 70, 74, 72 is 7, 0, 2, 4. Similar with 8 and others. 10, 10, okay, represent only 1. Okay. So the stand is for 60, 9 stand for 19 is represent T3 represent is twice in the 63. Okay. And then the ISOs is 95, ISOs 95. Okay. 653 means is 93 Fahrenheit. Okay. So the step, the first digit number and the leaf the second number.